Ladies and gentlemen, boys and girls, welcome back to another video. Today we're going to be going over the practice exam, which is now posted. The actual exam I have not written yet, so that's not going to be up there, but I'll probably write it hopefully maybe today or tomorrow perhaps. So we ended up going to the hospital on Tuesday. Actually, my wife had birth. We were planning on getting induced on Saturday, but she actually came early, so kind of hype, save money on the induction, right? All right, so let's get ahead and get into this. All right. Number one. So I actually kind of like this format, right? So this is what I would expect for the format. Here we've got 5 questions that are multiple choice. Here when it says describe your thought process, if I do multiple choice, I am probably going to err on the side of multiple choice being no partial credit, right? But there will be partial credit for these short answer responses, right? Okay, so go ahead and compute the limit. We're going to have the limit as x approaches -2 from the right hand side of ln of x plus 2, right? Oh. Okay, so how do we do this, right? Basically, what you're going to want to do here is you're going to say that we are ln of x. So this guy is what ln looks like, right? This is ln x. So we know that ln of 0 is going to be like going down to negative infinity. But here, it's ln of x plus 2. But same thing, you're plugging in -2, so it's going to be -2 plus 2 from the right. So you're going to be doing this ln of 0 from the right, you know. So it's going to be the same thing as if you just shifted, instead of this guy being x equals 0, now you make it x equals 2, and maybe x equals 0 is over here or something, right? So you're just shifting the function over to the right. But here, you're going to have the same thing. You're approaching from the positive side. You're going to be going down to negative infinity. Now, from the left-hand side, there is no approaching, right? So this would be dne. So dne would be as x approaches -2. Oh, sorry. So this would be -2, and 0 would be over here. It doesn't matter. It doesn't matter. X approaches -2 from the negative side would be dne, and then x approaches -2 from the positive side is going to be negative infinity. So the total limit would be dne, right? But here we're going to say negative infinity because we're going from the right. Okay, particle's position is given by this guy. Which of the following times, if any, is the particle at rest? Right, so we're going to say, guys, look, no way, no way, no way, no way, no way. 6, 7, that's insane. Okay, I didn't write this, right? So that's sick. Okay, so when it's at rest, right, that just means that the velocity is going to be 0, right? So how do we do this? There's a couple different ways. I would err on the side of so we can't formally take derivatives here because we're not doing the derivatives in the unit, right? Now you guys should know derivatives at this point, so you know that you want it to be velocity is 0. Here I would say we probably are going to need to do our we probably need to do our what's it called? Our difference equation form. It's like f of x plus h minus f of x over h, right? And you take h goes to 0. And you do this guy here, right? And then this guy is going to be the slope of your tangent line. We want this to be equal to 0, right? Because it means that it's at rest. So here, this is probably what I would do. I don't love these types of like kind of straight up computational questions, so I don't know if I would stress too much about this. But mind you, this is like, you know, this is kind of what you would do. You would just do this equation. You'd have 3t plus h squared, 4t plus h, 5. The 5's cancel. Maybe we'll do it together, but I wouldn't worry too much about something like this. This is going to be 3 times, what is it? -3 t squared plus 4t plus 5. -3 t squared plus 4t plus 5 minus -3 t squared plus 4t plus 5 divided by h. And now I will actually just go ahead. Now you would solve this, right? But I'm just going to go ahead and take the derivative. This guy here is going to limit. If you were to take this limit here, you'd end up getting what? Negative 6t plus 4. Negative 6t plus 4. Okay. We want... If you ever want something, make sure that you write want here, because this does not equal 0, right? You want to say that you want it, because this is just negative 6. It depends on your choice of t, right? It can be 0, but you want to make sure that you're very clear when you're doing stuff like this, like you're trying to solve for something, you want to say that you want it. Want this to equal 0, this means that t is going to be 4 over 6, right? 2/3. Am I tripping? Yeah, so it's 0.67. No way. You could draw kind of like a finger going like this, perhaps. I don't know. He's doing like little 6, 7. Okay. So it'll be this, right? Okay. Compute the limit. Here, if you ever see less than or equal to, in a limit sense, right? You are 100% of the time going to be using squeeze theorem. Yes, I can say. Maybe not like in... actually, I can't even think of when you ever would, like any math class that I've ever taken. That, like if you ever see a limit with an inequality, the squeeze theorem, always. So sometimes the squeeze theorem problems are more like you see sine of x is bounded or something like this. Like you actually have to go ahead and find your inequalities yourself. But here, I mean, if they're saying like this guy is less than this guy, less than that, right, they're kind of setting you up for it. So here, clearly, we see we'll compute the limit as x goes to 0. Well, what's the limit as x goes to 0 of this? Well, this is 0. This is 0. This is 2. Right. So this guy here would be a limit. Let me go ahead and get this here. Okay. So we go ahead and take a limit of all sides. This limit here is going to be 0, less than or equal to the limit of g as x approaches 0. Less than or equal to, what is the limit? What is e to the 0? Well, that's 1. That's going to be 2. Oh, this is 2. Sorry, this is 2. So 2 less than or equal to limit less than or equal to 2. By squeeze theorem, you have the limit is 2. Oopsie. Limit is 2. Okay, consider f is this guy right here. Then the limit as x approaches 3 is going to be 5. Okay, so you see we got this discontinuity here. They're defined differently. So you got to make sure that they both agree, right? And so here, these limits are very easy to take. What is the limit of x squared minus 4 as x approaches 3? Well, we can just plug it in. What's the limit of this guy as x approaches 3? We can just plug it in. Okay. So at this discontinuity, that's where the only place that we care about this like kind of continuity of this limit. So the left and right hand limits have to agree. So let's take this left hand limit first. Well, x squared minus 4. What is 3 squared minus 4? It's 9 minus 4 is 5. Okay. The left hand limit at least is 5. Sorry, my cat is being. Right hand limit. 2x minus 1. So we take 3, we plug it in. 6 minus 1 is 5. Right, so both of these limits are going to be 5. In other words, plugging them in are both. Now, if it was something that was not defined, consider like, I don't know, if you had like x squared over x, right? So x squared over x is defined everywhere except for at x equals 0. And it really is actually just. So it would just be like this straight line. If you had something like that, then you would actually have to take a limit. You can't just plug it in. But if you can plug it in, your limit, remember, is just plugging in if you're allowed to. Proof below, the proof below proves that the limit of this guy is 2. Okay, so let epsilon be greater than 0. Choose delta to be epsilon over 2. This is fine. Okay. If x is 2, is delta away from 2, right? So x minus 2, the distance from x to 2 is less than delta. Then negative 2x plus 1 plus 3 is less than epsilon. So you have a little bit of work to do. This is all a correct phrasing of the proof, right? So now you got to make sure that this actually does imply this. Right, so we're going to say negative 2x plus 1 plus 3. What is negative 2x? Negative 2x plus 1 plus 3, right? This guy, we want this to be less than epsilon. Well, let's simplify this. This is negative 2x plus 4. Less than epsilon. Want. And so now we can factor out a 2. Or negative 2, we'll call it, but the absolute value of... Okay, let's actually take some time with this. Let's factor out a negative 2. Because actually, now that I'm thinking about it, this might not be as trivial as as we want to make it out. Okay, it's because we have to be a little bit careful with absolute values, right? A real quick little rundown for absolute value. Absolute value of AB equals the absolute value of A times the absolute value of B. So what we can do here is the absolute value of -2 times x minus 2, which equals the absolute value of -2 times the absolute value of x minus 2, which is 2 times x minus 2, right? And reminder, x minus 2 here we said is epsilon over 2. So this guy here equals epsilon. Okay? So is this true? If x minus 2 is less than delta, then, okay, sorry. So I should have said that this is less than. This here is less than epsilon. Less than epsilon, and so we're good. That is proof complete. That's true. Okay, let's go to our next page. Determine whether the limit of f exists at x equals 2 if this guy is the case, right? So does the limit of f exist? Let's look at our left-hand limit and our right-hand limit. Remember, let me give you an example, because we got to be careful about this. What do you need for a limit to exist? You need the left-hand limit and the right-hand limit to exist. You don't need it actually to be continuous, right? So if I had a function like this, where this is an open hole, and the function is defined up here at this point, the limit does exist, and the limit is this guy right here, this point. Now, that's not, so this function is not continuous because the function value is not equal to the limit, but the limit does exist, and the limit is this one here. So that's where we kind of want to make sure we're not getting tripped up, right? Let's plug in 2 and let's see what we get. To plug in 2 here, we're going to get 4 minus 1, because 2 squared minus 1 is going to be 4 minus 1, that's 3. So the left-hand limit is 3. The right-hand limit is 5 minus 2, which is 3. So the limit equals 3, but f of 2 equals 1, so the limit exists even though f is not defined, even though f is not continuous. And we'd say, like, i.e., the limit is not the function value at 2. Find the equation of the tangent line at y equals root x at x equals 4. Okay. Here, once again, we don't have derivatives. I'm actually okay, so I take it back. I'm very fine with if I do not say, so we know derivatives at this when we take this test, right? You guys have no derivatives. If you want to use derivatives, if it makes it easier and you know that you can use derivatives, go for it. If I say do not use derivatives, that is the only time that you can. So I'm going to redact this problem 3 or whatever it was on the last one where I didn't use it, or I said you would use the algebra. You don't have to use the algebra. You can do the derivative. Let's go ahead and do the derivative here because it's going to be a lot quicker. But you can always do your difference equation, like f of x plus h minus f of x divided by h. Okay. So here, the equation of the tangent line at x equals 4. Okay. So we need an equation of a tangent line. So equation of a line. Equation of line. What do we need? We need slope and we need intercept. This slope we get via derivative. And this intercept we get via plugging stuff in. And that'll make more sense when we get to it. Plugging in. Okay, so let's get the slope first. So what is this guy? Y equals root x, right? So y equals root x. This is x to the 1/2. This means that y prime is going to, and this little arrow here just means implies. Like A implies B means that if A is true, B is true, right? If you're a square, square implies rectangle, right? Because if you're a square, then you're a rectangle. So if x is if y equals x to the 1/2, then y prime is going to be 1/2 x to the negative 1/2, which is 1/2 x to the 1/2, which is the same thing as root x. You can leave it as this. You can leave it as this. I'm going to write this because this looks kind of clean or whatever. This is how I would do it if I were doing the exam, right? Always, I like to leave my powers as numbers because if you want to take 2 derivatives, well, now you can just do it again. You don't have to like rewrite this as 1/2 and then do the whole thing. You know, you don't have to keep going backwards and forwards. I would just leave it as x to the negative 1/2. Okay. So, whoopsie, sorry. Okay, so we've got this now. This means what is our slope at the point? Well, our slope here, that's at 4, right? So y prime of 4 can be 1/2 times root 4, which is 1/2 times 2, which is 1/4. Okay. So our slope is 1/4. If you write 1/4 as your answer, that's wrong, because that is just a number, right? It's not. We need the equation of a tangent line. Okay. So now we know y, so now number 2, we're going to say y equals mx plus b, which equals 1/4 x plus b. Now we just need to find our tangent line, right? Then you do this just by plugging something in. So what's a point that we have? Well, y equals root x at x equals 4. What is y, right? So right now what we've got this guy here. This is y equals root x. This is x equals 4. X equals 4. This is really x equals 0, so I didn't draw it as well as I could have. But so we know that this slope here is going to, and this should be touching. Sorry, I'm not great at drawing. This is going to be 1/4 as our slope. But we need to find this point here. What is this point? Well, it lies on y equals root x, right? This is the same thing as y of 4, right? So what is y of 4? Well, this guy equals the square root of x, which is just... So we know that 4, 2 is the blue point. Okay, so now we've got a point. Well, we just plug this in here. So y equals mx, and x here is plus b. And I just solve for b. Because that'll give you, we're like backtracking to get this intercept. This is b here. 0b, y equals b. Okay, so we just backtrack, we solve, and we're going to say 1/4 times 4 is going to be 1. So 2 minus 1 equals b. B equals 1. So our final thing is going to be 1/4 x plus 1. Y equals 1/4 x plus 1. For the next 4 questions, consider this guy here. What's the domain of f? Okay, so when we think of domain, rational functions can't equal 0, and square roots have to be positive or greater than or equal to 0 on the inside. Otherwise, domains are pretty much always defined, like all real numbers, right? Mostly, like if I give you a polynomial or e to the x or something like this, ln, once again, ln has to be positive, like it's going to be greater than 0. It's not defined at 0 or negative. Just try to get a vibe of the picture of the function in your head, right? And once you know what it looks like, you're like, okay, it's got to cut off there. What is the domain of f? Well, I don't know. What's this guy here? It says express all answers in interval notation. So saying like r or real numbers, we're not going to do that. We're going to say our intervals here. Okay, so remember infinities. So here, okay, let's just look at f. F, this is defined everywhere but 0. You can't divide by 0, but you can divide by anything else. So we know that it's going to be negative infinity to 0, right? 0 is not included because you can't divide by 0, and negative infinity is not included because you're never you're not like infinity is not a number, right? So there's always parentheses. There's never a bracket on infinity. And then we're gonna have what? Well, we've got 0 to infinity. So this is the whole real line except for 0. We've just excised 0 here, right? Because they're both open parentheses. What's the domain of g? Well, g here, the inside has to be positive or greater than or equal to 0. So 3 minus x, we can do a little bit of algebra here if we're not super confident just looking at it. We can do a little bit of algebra. We're going to say that square root of 3 minus x, this guy here, we say 3 minus x has to be greater than or equal to 0, and this means that x has to be less than or equal to 3. This makes sense. If you plug in 3, you're going to get 0. If you plug in any number bigger than 3, well, now you're doing 3 minus 4, like a bigger number. This is going to be negative 1. You can't do that. Since we're subtracting x, it's actually going to be, our function is going to look something like less than 3, something like this, right? We've inverted. Okay. So it's going to be negative infinity to 3. But here it's a bracket, right? This is a bracket because 3 is included. If you plug in 3, you have square root of 0, which is 0. We're fine with that. The domain of f of g. Okay, let's think about this. F of g. So f of g is going to be 6 divided by g of x. Right? So here, once again, the bottom cannot be 0. So when is the bottom 0? So bad points. I like to just list the bad points when I'm doing domains, right? So what are the bad points? It's when the bottom is 0. Bottom is 0. And then i.e. Root 3 minus x equals 0, which means that x equals 3, right? Because it'd be square root of 0, 0. So x equals 3 is bad. Also, when square root is negative, like the inside of the square root, inside. And so that's going to be the exact same thing as this guy here. So this is when, so we've got x is less than or equal to, so this is when x is greater than, is bad. Right, so we can say, so here, so the good points, in other words, are going to be negative, like anything but 3, and then anything less than or equal to 3, which means that it's got to be both. Both have to be satisfied. So here we would say that x is less than 3. We'd say negative infinity to 3, not included, right? Because here, we know that the square root is not defined if x is, we can say x is less than or equal to 3 for this square root to be okay. But now, because x root 3 minus x is on the bottom, x being 3 is actually also bad, because then you have to divide by 0, right? And then g of f, very similar question, right? We're just going to have g of f. G of f of x, right, is going to be square root of 3 minus 6 over x. Okay. So the bad points here, first off, it's when you divide by 0. Divide by 0. i.e., x equals 0 is bad, right? Because here you'd be dividing by 0. Also, inside square root is negative, right? I'm just going to copy this. Exact same. Oh, okay. That square root is negative. Okay, so when is this guy going to be negative? Well, this means that 3 minus 6 over x is negative, less than 0. Oh, am I tripping? Did I do this wrong? No, okay, I've... This is why I was doing the good points, and this I'm doing the bad points. So I apologize if this is... Just do it whatever way you want. But, you know, I had to try to... Especially with these like convolution or like compositions here, like g of f. It's better to just get all the bad points. I think it's like simpler that way. Because any bad points are going to mess you up. Not just like the good points of this and the good points of this, and then you combine it because something might be a good point. For instance, here, 3 is a good point for the square root, but it's not a good point for the fraction, right? So you got to be a little careful with that. Okay, so 3 minus 6 over x is going to be less than 0. This is bad. This means that 3 is less than 6 over x is bad. We multiply and divide, x is less than 2 is bad. Right? So if x is less than 2, we're bad news bears. This is not great. So that means here, we're going to say that, so for it to be legit, so then for this to be legit, we need x is greater than or equal to 2, and x is not 0. Right? Because here x is 0 is bad, x is less than 2 is bad. But x is greater than or equal to 2, right? If you're just looking at your number line, this is 0 and this is 2. This is 0. We're saying it's got to be greater than this guy and not this guy. Well, that's already the same. So it's just me x is greater than or equal to 2. In other words, we say that 2 included is fine because it's greater than or equal to. And then we go up to infinity, parentheses. All right, that is the whole practice exam. I hope that you all have a good time studying. Email me if you have any questions. And the test should be like next Thursday, if I'm not mistaken. It will be something like this. I like this format here, so it'll probably be multiple choice at the beginning. Don't expect really any partial credit there. It'll be short answer at the end. I may do an extra credit problem. I like doing extra credit problems, but I'm not sure how well this format will lend itself to it. So we'll kind of see what the vibes are for that. But if you have any questions, feel free to email me, and I hope that you all have a wonderful day and a good weekend. Take it easy.